Welcome back guys to Mathematical Mindset. Right here on the series of matrices. In today's video we're going to talk about the transpose of a matrix. Now if A is equal to a matrix of the same row of the same column is a m by m matrix, the transpose of A denoted by a raised to the power of t is an n by m matrix, whereby we have a raised to the power of t of the same row and the same column is equals to A of the column in row. Now I'm going to explain what this simply means as we go on in this video. The transpose of a matrix A is written or denoted as A raised to the power of t or A prime. Now let's take a look at the examples right here. Now a 2 by 3 matrix, let A be equals to 1, 2, 3, 4, 5, 6. Now look for the transpose of this. So we have A to be this, so the transpose is going to be given as, transpose simply means you want to simply interchange the row and column. Now for this row right here, which is 1, 2, 3, now the row is going to become a column, which is 1, 2, 3. So the second row is going to become a column, which is 4, 5, 6. So this becomes the transpose. It's as easy as it is, and this is a 2 by 3 matrix. Now for a square matrix, which is 3 by 3, we have B to be a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. So to look for the B transpose of this, all we have to do is to interchange the row and column. So for the first row, we have this to be 1, 2, 3, which is going to become a column. For the second row, it's going to become a column, which is 4, 5, 6. And the third row is going to become a column, which is 7, 8, 9. And we have been able to look for the transpose of a 3 by 3 matrix. It's as easy as this right here. Now let's take a look at the properties of a transpose. Now the first property right here, we have the double transpose. The transpose of a matrix is the original matrix. If you transpose a matrix twice, it is equal to the original matrix. Let's verify this by making use of this example question here that says, verify that the transpose of a matrix is equals to A. For A is equals to 2, negative 1, 5, and 3. So let's simply solve this. So let's look for the A transpose. Now the transpose of this, we want to simply interchange the row and column. So for the first row, we have this to be 2 and negative 1. Then the second row, we have this to be 5 and 3. So we have been able to look for the first transpose. Now the transpose of A, which is A transpose into another transpose. So we are going to transpose this matrix here, and we are going to have this to be interchanging the row. We have this to be 2, 5. Then for the second row, we have this to be negative 1, 3. And this is equal to A. And A is given as 2, negative 1, 5, and 3. And this is it. We have been able to verify that the double transpose, which states that the transpose of a matrix is the original matrix, holds for this example right here. Let's take a look at the second property. Now the second property is the property of a sum. The transpose of a sum of matrices is the sum of their transposes. This implies that if A plus B transpose is equal to A transpose plus B transpose. So let's use this example right here to verify if this property holds. So the first thing, guys, we have two matrix A and B. So the first thing we want to do is to simply add A plus B, the matrix A and the matrix B. So adding this, we have this to be 1 plus 5, 2 plus 6, 3 plus 7, and 4 plus 8. Now if you are wondering how did we add this matrix, you want to simply go to my previous video on addition and subtraction of matrices. So from this, we have this to be 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. So we have this right here. So taking the transpose of A plus B, so we have A plus B transpose will be equal to, so take the transpose of this by interchanging the row and columns. So for the first part, we want to simply interchange the first row, and the first row to become a column is going to become 6, 8. Then the second row is going to become 10, 12. So we have been able to get the transpose of this. So let's simply verify the right hand side. So verifying the right hand side, we have that A is equal to, the matrix of A is given as 1, 2, 3, 4. And we have B to be equal to 5, 6, 7, 8. Alright, so let's take the A transpose. This is going to become the A transpose, interchanging the row to be a column. We have 1, 2, for the second row 3, 4. Then the B transpose is going to give us 5, 6, 7, 8. Alright, so we have this right here. Alright, so I've been able to get this. So adding A transpose plus B transpose, this is going to be equal to A transpose is 1 plus 5, 3 plus 7, 2 plus 6, and 4 plus 8. And this is going to equal to 1 plus 5 is 6, 3 plus 7 is 10, 2 plus 6 is 8, and 4 plus 8 is 12. So we have, this is the first one right here, and this is the second one. See, for A plus B transpose, we have 6, 10, 8, 12, and A transpose plus B transpose, we're able to have 6, 10, 8, 12. So from here, we can easily state that the left hand side is equal to the right hand side. So this property of a sum holds. So let's go to the third property, and the third property right here is scalar multiplication. The transpose of a scalar multiple of a matrix is the scalar multiple of the transpose. That is to say, if you multiply a matrix by a scalar and take the transpose of that matrix, it is equal to the scalar multiplying that matrix transpose. So let's verify it using this example right here. So we're going to check if the left hand side is equal to the right hand side. So they said let A be equal to a matrix of 0, 1, negative 2, and 3, and the scalar, which is K, is equal to negative 4. So for the first part, we want to simply look for KA. That is multiplying the scalar with the matrix. Alright, so this is going to become, now the scalar is negative 4, so we have negative 4 multiply 0, negative 4 multiply 1, negative 4 multiply negative 2, and negative 4 multiply 3. So this is equal to negative 4 multiply 0 is 0, negative 4 multiply 1 is negative 4, negative 4 multiply negative 2 is positive 8, and negative 4 multiply 3 is negative 12. So we have this. So taking the transpose of this, so taking the transpose of KA transpose will be equal to interchanging the row to be a column. So for the first row, we have 0 and negative 4. And the second column right here, we have 8 and negative 12. We have been able to solve for the left hand side. So let's solve for the right hand side. Alright, so to verify for the right hand side, now we have A to be equal to a matrix of 0, 1, negative 2, and 3. The right hand side, we want to simply verify K all into A transpose. Alright, so we're going to take the transpose of this. So the transpose is equal to, now interchanging the row, we have 0, 1, negative 2, and 3. So this is the transpose. So for K into A transpose, we have that K is equal to negative 4. So this becomes negative 4 multiply 0, negative 4 multiply negative 2, negative 4 multiply 1, and negative 4 multiply 3. And this is equal to negative 4 multiply 0 is 0, negative 4 multiply negative 2 is 8, negative 4 multiply 1 is negative 4, and negative 4 multiply 3 is negative 12. And this is the right hand side. So therefore, if you look at this right here, this is the left hand side and this is the right hand side. So therefore, we can say that the left hand side is equal to the right hand side, and that we have been able to prove the scalar multiplication property. So the fourth property of a transpose is the matrix multiplication. The transpose of a product of matrices reverses the order of multiplication. Now this implies that if you take the transpose of AB, this is equal to B transpose multiply A transpose. Alright, so let's simply take a look at this example to verify this property. So we have AB transpose, so we want to simply multiply A and B. So multiplying A and B, we have 1 multiply 2 plus 0 multiply 0. Then we have 1 multiply 3 plus 0 multiply 4, minus 1 multiply 2 plus 2 multiply 0, then minus 1 multiply 3 plus 2 multiply 4. And this is equal to 1 multiply 2 is 2 plus 0, 1 multiply 3 is 3 plus 0 multiply 4 is 0, negative 1 multiply 2 is negative 2, 2 multiply 0 is 0, negative 1 multiply 3 is negative 3, plus 2 multiply 4 is 8. So this is equal to 2 plus 0 is 2, 3 plus 0 is 3, Negative 2 plus 0 is negative 2, and negative 3 plus 8 is 5. So we have been able to solve for the matrix of AB. Now taking the transpose of AB, this is equal to, so interchanging the row and column, this becomes 2, 3, negative 2, and 5. So we have been able to verify the left hand side. So let's verify the right hand side. So for the right hand side, now we have that A is equal to 1, 0, negative 1 and 2, and B is equal to 2, 3, 0, 4. Okay, so we are going to verify B transpose and A transpose. All right, so let's solve for B transpose. This is equal to, so finding the transpose of B, this becomes 2, 3, 0, 4, and A transpose becomes 1, 0, negative 2. All right, negative 1 and 2 rather. So multiplying B transpose and A transpose, this is equal to 2 multiply 1 plus 0 multiply 0, 2 multiply negative 1 plus 0 multiply 2, 3 multiply 1 plus 4 multiply 0, and we have 3 multiply negative 1 plus 4 multiply 2. Alright, so from this point we have this to be equal to 2 multiply 1 is 2 plus 0, negative 2 plus 0, 3 plus 0, and negative 3 plus 8. Alright, so this is equal to 2 plus 0 is 2, negative 2 plus 0 is negative 2, 3 plus 0 is 3, and minus 3 plus 8 is 5. Alright, so this is the right hand side. So let's simply check if this is correct. So for the left hand side, we have 2, negative 2, 3, and 5. And for the right hand side, we have 2, negative 2, 3, and 5. So this is to say the left hand side is equal to the right hand side, and hence the multiplication matrix property actually holds. So lastly, the last property of transpose is the symmetric matrix. Now a matrix is symmetric if it is equal to its transpose. So if the matrix is equal to its transpose, then that type of matrix is a symmetric matrix. And now there is an example that we can actually use for this. Alright, so for example, we have this matrix A to be x, 2, and 2y. Okay, now we have to find x and y such that A is symmetric. Alright, now for A to be symmetric, it simply implies that the matrix must be equal to the transpose of that matrix. Alright, so the top left of this matrix, which is x, and the top bottom, which is y, remain unchanged. Now that simply means that we cannot interchange the top left and the bottom right. We cannot interchange this. So not interchanging this and look for the transpose of this. This becomes, since x and y are not interchangeable, we have this to be x, y. So interchanging the top right and the bottom left, this becomes 2 and 2. So this is to show you that the matrix A is equal to its transpose. Alright, so we have been able to prove that this matrix is a symmetric matrix. So right here, these are the basic things you simply need to know when you are talking about the properties of a transpose and the transpose of a matrix. So right here, guys, in the next video, we're going to go into another topic on matrices. So guys, if this video is really helpful to you, please do not forget to turn on your post notification, and do not forget to give this video a thumbs up, subscribe to Mathematical Mindset, and I'm going to see you in the next video.